Assalamualaikum and good day everyone. So today we are going into the last part of 6.2, trends in some key periodic atomic properties. So let's have a look at the learning outcome for today. So by the end of this lesson, you should be able to define electronegativity and also first ionization energy. Okay, and then we are going to explain the variation in electronegativity and also ionization energy across the period 2 and 3 and also down the group 1 to 13 to 18. Okay, so I think there's really no problem here at all actually, because we are going to use the points that we have learned before, which is the PSAS and also NSAS, to explain the variation. Okay, however, we are going to relate those points with electronegativity and also ionization energy. We are going to have a look how all the points are going to affect ionization energy and also electronegativity of an element. Okay, but first you have to understand clearly what is meant by electronegativity and also ionization energy. So let's have a look at the electronegativity first. Okay, so what is electronegativity? It is the relative tendency of an atom to attract electrons to itself when chemically combined with another atom. Okay, so meaning this is actually for molecule lah. Okay, so for example we take hydrogen gas. So hydrogen gas, hydrogen dengan hydrogen kan, kita ada dua hydrogen atom, whereby these two atoms diorang akan share diorang punya electron with one another. Okay, but then since dia adalah dua atom yang sama, so dia macam tak adalah satu yang akan tarik lebih compared to another one. Okay, compared to kalau kita guna dua atom yang berbeza, okay, so dia ada electronegativity yang berbeza. Okay, kalau tadi dua atom yang sama, electronegativity dia sama, so tak ada one atom yang akan attract another one punya electron towards itself lebih. Okay, tapi kita focus more on when the two atoms are different. For example, if we have HCl, okay, so in the case of HCl, chlorine is more electronegative than hydrogen. Okay, jadi untuk diorang ni, diorang akan share diorang punya elektron nanti. Jadi di elektron yang diorang share tu nanti, since chlorine is more electronegative, okay, they both, the electron pair, okay, so the electron pair, they will spend more time around the more electronegative atom. Okay, so let's have a look at this diagram here. Okay, so yang color merah ni hydrogen punya electron, meanwhile the blue cross is the Cl punya electrons. So this is the one yang they share with one another. Okay, so they share it. However, since Cl is more electronegative, so the atoms, okay, this particular bonding pair of electrons, dia akan spend lebih banyak sebelah Cl punya side compared to hydrogen. Okay, since Cl has more electronegativity. So apa yang menyebabkan Cl being more electronegative compared to hydrogen? Okay, so let's have a look at that. Okay, so this one we are talking about across a period lah. Okay, so you know that by now, you should know that across the period, proton number increases. Okay, and also the effective nuclear charge also increases. So this is the ZeV. Okay, effective nuclear charge adalah ZeV. So what happened next? So the electrons, they are closer to the nucleus. Okay, so electron of atom tu sendiri pun dia akan tarik kuat, attracted kuat kepada nucleus. So bila dia share with another atom pun, okay, so dia ada possibility ataupun ada tendency untuk attract electron yang dia share tu pun akan tarik ke diri dia juga. Itu definition electronegativity tadi kan. Okay, so what happened is the atomic size decreases. Okay, so the electronegativity increases. So sebenarnya dia ada kaitan dengan size lah. Okay, so lagi kecil size sesuatu atom tu, we know that the attraction forces between the valence electron and also the nucleus yang dekat tengah-tengah tu kuat kan. So in the case of bila kita buat electron sharing, okay, so elektron yang diorang share tu pun dia akan tarik kuat juga ke arah diri dia kalau saiz dia kecil. Okay, So itu tadi yang kalau across period. So now let's have a look going down the group. So by now you should know that going down the group, size makin besar kan makin kecil. You should know already. Okay, so when principal quantum number increases, okay, as we going down the group, principal quantum number increases, value n. Okay, so the shielding effect increases. Okay, so the electrons are further apart from the nucleus. Okay, so kalau dia nak tarik valence electron dia pun susah, elemen tu. So bila dia share pun elektron dia dengan another atom, another element, of course yang dia share tu pun susah untuk dia tarik ke diri dia juga. Okay, so here the nucleus attraction towards the valence electron weaker, therefore the atomic size increases, dia makin besar. Jadi in terms of electronegativity pun dia akan menurun. Okay, so basically kita guna je PISAS and NSAS dekat sini. It's just that lepas tu kita relatekan dengan electronegativity. Basically, if the forces interaction between the nucleus and also valence electrons are strong, therefore the tendency untuk that particular atom to attract electron, bonding electron towards itself is also high. Bermaksud electronegativity tinggi dekat situ. Okay, but if the other way around, then electronegativity menurun. Okay, so in general, a small atom has a greater ability to attract the bonding electrons to itself because the bonding electrons are closer to nucleus. Okay, meanwhile, larger atom has a weaker ability to attract the bonding electrons to itself because the electrons are further from the nucleus. So electronegativity increases across period and decreases down the group. Okay, jadi secara generalnya, kalau kita discuss pasal across period, okay, so we are going to use the PISAS. Okay, and then kamu tambah je pasal electronegativity. Okay, relate je dengan electronegativity. So kalau kita tengah cakap pasal yang going down a group, okay, if the elements are in the same group, okay, so kalau sini kita guna point NSAS and then relatekan je dengan electronegativity. Okay, so negativity. Okay, jadi kat sini kelas saya kalau kamu dah tahu size tu, daripada size tu kamu dah boleh figure out dah whether the electronegativity is actually tinggi ataupun rendah. Okay, so this I think okay, this is the predictable just to show you that going across the period, the electronegativity increases, going down the group, the electronegativity decreases, and also dekat dalam predictable ni ada value-value sebenarnya. Okay, so class kita tak tengok in terms of kita punya inert gases because inert gases dia dah stable dah. Okay, and there's no possibility for it to share its electron towards another atom and so on. Okay, sebab tu dia tak ada value. Okay, dia tak ada value electronegativity. Tapi antara semua yang lain kecuali group 18, so fluorine is the smallest atom. Therefore, fluorine has the highest electronegativity. Okay, so dia punya value electronegativity dia adalah 4.0, followed by oxygen. And then the next one is nitrogen. So phone lah, Miss panggil ni phone. So phone are the 3 most electronegative atom. Okay, so you should know this because yang ni nanti kita akan guna pakai this particular info here. Kita akan guna pakai in the next topic. Okay, so next, okay, yeah, you have to try this question here. Okay, you just have to arrange the elements in order of the increasing electronegativity. So arrange, so ada dua cara arrange lah. So let's say I give you A, B, C, D. Okay, so ini adalah increasing order of electronegativity. Jadi ada dua cara nak jawab kelas. Sama ada kamu nak guna yang, ingat tak Miss saja guna yang more than or less than. Okay, so in this case kamu akan guna yang less than lah. So let's say A is smaller than C, smaller than D, smaller than B. Okay, let's say this is the answer. So you can write your answer this way. Okay, ataupun satu lagi cara adalah A, kamu guna je koma. Tapi kalau guna yang koma ni, kamu kena tunjuk arrow kat bawah ni dan kena tulis increasing order of electronegativity. Okay, so this arrow here, it needs to always be like from left to right. So even if the question asks for decreasing order of electronegativity, you still have to make sure the arrow is from left to right. Okay, kamu kena susun yang daripada, kalau decreasing maksudnya yang paling besar kepada yang menurun lah, paling kecil lah. Okay, so make sure the arrow is always left to right. So jawab macam ni. Kadang-kadang ada yang prefer yang bawah ni, because kalau jenis yang confuse simbol ni, better kamu guna cara bawah ni. Tapi kalau kamu okay je dengan simbol ni, kamu tak confuse dengan simbol ni, then opt for option 1 lah. Okay, or kalau confuse, opt for option 2. Okay, so there's no need for you to explain, but if you want to, you can do so. Okay, so the next one is kita tengok kepada the first ionization energy. So ada second ionization energy, third ionization energy, and so on. Okay, so kalau secara generalnya we just call ionization energy lah, but specifically we are talking about first ionization energy. So what is first ionization energy? So first ionization energy, ataupun kalau ionization energy ni sebenarnya kita akan singkatkan dia sebagai IE. Okay, kamu pun boleh singkatkan dia guna IE as long as kamu dah mention dahulu ionization energy dalam kurungan IE. Boleh je guna IE lepas tu. Tapi kalau first time baru nak guna, then you have to specifically tulis penuh ionization energy. Okay, is the minimum energy required to remove 1 mole of electron from 1 mole of neutral gaseous atom. Okay, so kita akan remove 1 electron daripada dia punya atom. Okay, specifically kita nak cakap pasal remove electron, satu electron from atom dia. Okay, because once kita dah remove 1 electron dia daripada atom, so dia dah tak remain sebagai atom kan, because if we remove the electron, dia now dah jadi cation kan, so dia dah jadi ion dah, because kadang-kadang ada elemen yang remove more than 1 electron. Mungkin dia remove 2 electron. So the next one, the second electron yang dia keluarkan tu, so that will be the second electron dah. So yang tu adalah second ionization energy sebenarnya. Okay, tapi ayat dia akan berubah lah. Dia bukan yang 1 mole of electron from the gaseous atom dah. Dia akan daripada gaseous ion dia pula dah. So ionization energy ni ada banyak, tapi specifically we are just focusing on the first ionization energy, where first ionization energy is the minimum energy required to remove 1 mole of electron from 1 mole of a neutral gaseous atom. Okay, specifically daripada atom dia. So macam ni lah. So yang ni kita letak face dia lah, gas. So ini adalah dia punya neutral atom. So kita remove 1 electron dia. Okay, so now dia jadi X positif kat sini. Kan, kita donate electron, dia jadi positively charged ion. Okay, so the higher the ionization energy, the more difficult it is to remove the electron. Maksudnya kat sini, kalau kamu tengok value IE tu besar, bermaksud susah sebenarnya kita nak remove that one particular electron tu. Tapi kalau tengok another element pula, ionization energy dia rendah, bermaksud sebenarnya nak keluarkan elektron daripada that particular element is actually senang, easier compared to the other one. Okay, so lagi tinggi value tu meaning lagi susah kita nak remove that electron here. Okay, so what are the factors affect the value of ionization energy? So ada 3: atomic radius, effective nuclear charge, and also shielding effect. Okay, sebenarnya these two factors here actually yang akan affect the atomic radius kan. Okay, tapi basically daripada atomic radius as long as you know the size, sepatutnya kamu boleh terus relate dengan ionization energy. Okay, tapi keep in your mind that after all the atomic radius is actually affected by these two factors here. Depends lah. Okay, so first kita tengok dahulu yang atomic radius. Okay, so atomic radius ataupun the size of the atom itself. If the atomic radii is large, okay, so if it's large, therefore the nucleus attraction towards valence electron is weak between apa ni tadi? Antara nucleus dengan valence electron. Okay, bila dia besar, so the attraction forces are weak. So if the attraction forces are weak, so in order for you to remove electron, of course kamu akan remove electron from the outermost shell. Okay, kamu akan remove electron, valence electron. Okay, kamu tak akan remove simply yang daripada tengah-tengah tu. No. Okay, kamu akan remove from the outermost one. So kalau jarak dia jauh, attraction forces pun lemah, so senang tak nak keluarkan the electron from the atom. Okay, of course senang. Okay, because the attraction forces are weak. Okay, so less energy. So since it is easy to remove the electron, meaning less energy is needed to remove that one electron. Therefore, the value of IE decrease. Okay, so the value of IE is low. So kat sini we are talking about attraction forces, kuat ataupun tidak. And then kita akan relate dengan whether more energy or less energy is needed to remove electron, and then baru kita relatekan dengan IE, ionization energy. Okay, and then the next one is effective nuclear charge. Okay, so ada bunyi, Miss tak tahu kamu dapat dengar tak? This particular slides actually has side effect dia yang ada bunyi dia tu, tapi Miss tak pasti masuk ke tidak dalam Miss nanya, tapi Miss harap tak masuk lah. Mungkin Miss nak dengar apa ni tadi, bebel kerja Miss ni. Kita tengok effective nuclear charge. Okay, so effective nuclear charge ni specifically we are talking about a cross period lah sebenarnya. Okay, the one yang cross period. So across period we know that effective nuclear charge increases, meaning the attraction forces between the nucleus and also the valence electron are strong. Okay, so if the attraction forces are strong, so will you need more energy to remove the electron ataupun less energy? So since the kuat, of course you will need more energy to pull out one electron from the atom. Therefore, the ionization energy will be higher then. Okay, so yes, IE higher. And then the next one is kita tengok shielding effect, so ataupun screening effect. So going down the group, the screening effect increases sebab makin banyak shell. Okay, so the nucleus attraction, of course it becomes weaker sebab dah jauh dah. Okay, so bila dah jauh dah, bila dia dah lemah, so in order for you to remove one electron, so less energy is needed. So since less energy is needed, therefore the IE is lower. Okay, so dekat sini lebih kepada we talking about the attraction forces lah. Okay, attraction forces, more energy, less energy, and then baru kita cakap pasal IE. Okay, so generally going across a period, okay, we are going to use the pizzas. Okay, so proton number, and then kita cakap pasal ni P kan, and then kita cakap pasal ZEF, and then we are going to talk about the attraction forces, and then we are going to talk about the size. So more energy ataupun less energy, so yang ni adalah energy to remove electron. Okay, and then baru kita cakap pasal IE. So ini across a period. Okay, jadi specifically, generally going across the period, since the size becomes smaller, so attraction force is stronger, so the value of IE higher. Okay, it increases. So what about going down the group? So going down the group, number of shell increases. Number of shell increases ni berkaitan dengan principal quantum number n. Okay, and then screening effect increases. Okay, so the distance become larger. So yang ni we talking about the attraction forces lah kat sini. Okay, so since the distance larger, so attraction forces jadi lagi lemah. Okay, and then we going to talk about the size then. Okay, so next one baru kita pergi kepada yang energy, less energy ataupun more energy needed to remove electron. And then barulah kita cakap pasal IE. So dia macam ada dua extra point selepas ansas ataupun pizzas kan. Okay, tapi very simple sebenarnya ni. Jadi untuk period 2, period 3 pun ada juga sebenarnya, tapi we are only focusing on period 2. So for period 2 ada anomalous cases. Anomalous cases ni bermaksud case yang pelik sikit. Dia lari sikit daripada yang sepatutnya secara teorinya yang kita menjangkakan A, tapi tiba-tiba lari sikit, ada pelik sikit. Okay, so as you can see from this particular graph here, okay, supposedly we are expecting going across the period the ionization energy increases. Kan, macam mana kalau ada macam ni kalau misalnya kalau dalam kamera ni it's supposed to be increases. Okay, tapi as you can see in the graph here, dia naik daripada lithium pergi beryllium naik, tapi suddenly ada a drop here, a small drop here, and then dia start naik balik, and then there's another one sudden drop here, and then dia naik balik. Okay, so dia generally dia memang naik lah, tapi tiba-tiba dia ada sudden drop tu. So that particular drop there is the part yang anomalous cases dekat sini, dia macam pelik sikit. So let's see kenapa sebenarnya benda ni berlaku. Okay, so the increase of IE with proton number is actually not uniform. Okay, in period 2 there are two cases whereby kita akan tengok between group 2 and also group 13. Okay, antara beryllium and boron, and then next one adalah antara nitrogen and also oxygen. So let's have a look at the first case dahulu, which is between beryllium and boron. So somehow ionization energy of beryllium is slightly higher compared to boron. Supposedly kita expect boron higher lah, because boron is actually smaller. In terms of size, boron is actually smaller. Tapi why? Kenapa beryllium higher? Okay, so electronic configuration of beryllium is 1s2 2s2. Abaikan dulu yang fully filled ni, pasti kita pergi ke situ. Dan untuk boron pula, it is 1s2 2s2 2p1. So ini dikatakan sebagai partially filled orbital. Okay, we are focusing on the very last orbital. Bermaksud beryllium ni the highest orbital yang kita isi adalah 2s. Untuk boron pula the highest one is 2p. Okay, kita fokus dengan yang highest orbital sahaja. So fully filled ni bermaksud dia memang penuh lah, orbital tu penuh. 2s boleh isi penuh 2 kan. So 2s tu ni considered fully filled. Okay, meanwhile partially filled ni pula adalah as long as orbital tu terisi je, that is considered partially filled. Dia terisi 1 kah, 2 kah, okay, itu consider partially filled asalkan dia terisi. Okay, so 2p1, so terisi 1 dekat sini, so ini considered partially filled orbital. So what you need to know now is class, that fully filled orbital, okay, ataupun completely filled orbital, it is more stable than the partially filled orbital. Okay, so bila something yang very stable, so susahlah sebenarnya untuk kita remove electron tu. Okay, benda yang kurang stable sikit senanglah kamu nak remove sebenarnya. Okay, so mungkin kamu tak nampak sangat yang fully filled orbital, partially filled orbital. Okay, because the electronic configuration that that have been shown to you just now was SPDF notation. But now let's have a look at the orbital diagram. So mungkin yang ni lagi clear. So kalau kita tengok sini, ini adalah beryllium punya orbital diagram. Okay, and then this one pula adalah untuk boron. So macam saya cakap tadi, we are focusing only on the highest energy orbital. So ini 2s, okay, fully filled 2s orbital. Meanwhile, yang ni kita focus on the 2p. So as you can see, there's only one being added into the 2p orbital. So that's why they define it as partially filled 2p orbital. Therefore, class, removing an electron from the beryllium makes the atom less stable. Okay, so that is why more energy is needed to remove the electron. Okay, therefore the ionization of energy for Be is higher compared to boron. As simple as that. Okay, dia berkaitan dengan stability. Which particular orbital is more stable? So disebabkan fully filled is more stable, that is why removing one electron from that actually requires more energy. Okay, so ionization energy pun jadi tinggi lah. Okay, that is for beryllium and boron. The next one is between nitrogen and also oxygen. Okay, so somehow kat sini nitrogen has a higher ionization energy compared to oxygen. So why is that? Okay, so in this case class, kalau kita tengok electronic configuration, so again Miss tunjuk yang SPDF saja dahulu. So untuk nitrogen, yang last kali ni 2p3. So ini dipanggil sebagai half filled orbital. So I think kamu boleh faham kot apa sebenarnya half filled ni. Okay, compared to oxygen, so oxygen ni ada 4. Okay, so 4 ni it is macam mana? Kalau yang 2p ni kita boleh isi maksimum 6 kan? Okay, so kalau 6 fully filled. Okay, Kalau kita isi half je, 3, that is considered half filled. Okay, tapi any other numbers yang kita isi, maksud kalau kita isi 1 kah, kita isi 2 kah, kita isi 4, kita isi 5, itu considered sebagai partially filled orbital. Okay, this is not only for 2p, this is also for d orbital. D orbital pun boleh juga. Okay, s orbital tak perlulah, because s orbital we only have 2 kan, electron. Dia kalau ada 2, dia full. Kalau ada 1, dia half. Okay, so kita tak tengok sangat tu. Kita more to yang p orbital ataupun d orbital. Kita cakap yang fully filled ataupun half filled. Okay, so in this case class, half filled orbital is more stable than the partially filled orbital. Okay, so ada 2 lah yang kamu kena ingat kat sini. Okay, 2 points yang kamu kena ingat. Fully filled orbital more stable than partially filled orbital. Half filled orbital is more stable than the partially filled orbital. Basically, partially filled orbital kurang stable. Okay, so kalau kita tengok, kalau kamu tak nampak sangat tadi, so kalau kita tengok orbital diagram kat sini, I think it is more clear now. Okay, so as you can see, 2p orbital, semua satu orbital yang ada dekat 2p ni terisi dengan satu elektron. Okay, so itu considered sebagai half filled. Okay, meanwhile, kalau untuk oksigen pula, as you can see here, okay, so this is not considered as half filled lah. Dia terisi, but it is neither half filled or fully filled. Okay, so kita just panggil itu sebagai partially filled. So what you have to know is removing 1 electron from the half filled p orbital, it makes the atom less stable. Okay, therefore it requires more energy. Okay, because dia dah sangat stable dah sebenarnya. You have to know that the 2p orbital, the half filled 2p orbital is very stable already. So kalau kamu remove 1, dia akan menyebabkan benda tu jadi sangat tak stable. So tapi kalau nak remove juga, it will require lots of energy. Okay, that is why the ionization energy of the nitrogen is higher than the oxygen. Okay, so in general class, again, dia sama case tadi, sebenarnya semua ni ada kaitan dengan the size actually, be it electronegativity ataupun ionization energy. So in the case of ionization energy, a small atom is harder to remove 1 electron from it. Okay, this is because the forces of attraction between the nucleus and also the valence electron are very strong. Okay, so bila dia very strong, so it will be harder lah untuk kita remove. You will need more, it will need more energy to remove 1 electron. So that's why ia akan tinggi. Meanwhile, kalau large atom, it is easier to remove 1 electron. This is because the nucleus attraction is already weak. So senang je lah dia ambil. Okay. So first ionization energy increases across a period and decreases down a group secara generalnya. Kalau kita abaikan di anomalous cases, tapi you have to know about the anomalous cases, right? So this is the general trend in the first ionization energy: going across, increase; going down, decrease. Okay. So now try this 6.0. So again, kamu just perlu arrange sahaja. There's no need for you to explain it. But this time round, you have to arrange this in order of decreasing. Okay, so kena tengok betul-betul. So yang paling senang adalah tengok dia dalam period yang sama kah, dia dalam group yang sama kah. Try to identify that first, and then daripada situ you can identify whether the size is smaller or larger, and then daripada situ nanti kamu boleh try to relate with the ionization energy. Same goes to the try this 5.0 just now. Okay, boleh try relatekan dengan electronegativity once kamu dah figure out the size of the atom. Alright, itu sahaja kelas. So don't forget to submit the try this 5.0 and also 6.0.